Hi everyone, thanks very much for joining us today at this Tech for the Global Goals track and specifically to this session on conservation technology with Wildlabs. My name's Fran and I lead social impact and innovation at ARM, and today I am delighted to be joined by Alasdair Davies, Director of Arribada Initiative and a Shuttleworth Foundation Fellow, and Shah Selbe, founder of Conservify and FieldKit, who today are going to be sharing with you some of the technical challenges they face as conservation technologists. To introduce the session briefly, I wanted to start with the goals, what we've named this track after. COVID-19 has clearly highlighted the interconnectivity and fragility of the systems that hold our lives together, and we've been forced to reevaluate the way that we live, the way that we work, and the way that we connect with the world around us. And the world's now looking at how we can ensure long-term and long-lasting, sustainable and equitable resilience as we rebuild post-COVID. Through this Tech for the Global Goals track, and specifically this session, we're looking at social innovation at the application level and asking how individuals, developers, engineers and organisations can use this turning point as an opportunity to build a better, fairer economy and society for everyone. In 2015, world leaders from all 193 member states of the UN agreed to these 17 interconnected global goals with the aim to create a better world by 2030. Ending poverty, fighting inequality, and urgently addressing the climate crisis. Each goal has a list of targets, and within each target are a set of indicators that are used to measure progress towards the goals. Of the 169 targets, 70% of them can be directly supported by advanced technologies, which means that the tech industry has a huge role to play in addressing some of the world's biggest challenges. These goals serve as the world's to-do list. You can't have healthy people on an unhealthy planet, just as you can't have sustainable business in an unsustainable world. The best way to make a great future is to invent it ourselves, and for those of you attending this session, you're in a unique position to do exactly that. And so today we're looking specifically at conservation technology and how technology can be used to restore and promote sustainable use of ecosystems that are crucial to our existence. Alongside the huge shifts that are happening in the computing market, there's huge shifts happening for people and planet too, as we push the Earth's resources and systems to their extremes. The use of technology is key to understanding the rate of change that we're seeing. One of the platforms that's facilitating this kind of thinking between conservation and technology is Wildlabs, a platform that brings together conservationists and technologists to share information, ideas, tools and resources to discover and implement technology-enabled solutions to some of the biggest challenges we're facing. From camera traps for wildlife monitoring, acoustic sensors assessing trends in animal and human behaviour, to drones and satellites monitoring the impact and rate of ecological change. Conservation technology is increasingly critical to ensuring that people and nature survive and thrive. ARM has been a proud partner and funder of Wildlabs since its inception, providing the initial seed funding to get the platform off the ground alongside Google.org back in 2015. And so I'm very pleased to now hand over to two members of that community, Al firstly, followed by Shah, to tell you more about their work. Over to you, Al.
Thank you very much, Fran. So I'm Alasdair Davies, and I'm the Director of the Arribada Initiative, and I'm also a Shuttleworth Foundation Fellow. I'm here today to tell you about two very exciting uses of edge machine learning in conservation. So my first task of using edge machine learning has been to detect the presence of polar bears. So a very charismatic species, but also a very threatened species. We all know that polar bears are affected by climate change, and the loss of sea ice is having an inherent effect on our ability to find food. Now, my job has been to develop a system to detect the presence of polar bears 24/7, has to be battery operated, it has to operate in temperatures as low as -40 degrees C. It's a very challenging environment to deploy technology within. And ultra low power consumption is key. I need to know that what I'm developing can operate for extended periods of time, be very limited in its power consumption, because I can't rely on solar panels and traditional forms of power. And for me, developing a system like this has been a challenge for the last 2 years. I'm going to tell you about those challenges that I've had to undertake and how I've got around them with really low powered microcontrollers and edge machine learning. But it's not just polar bears I've been looking at as well. I've also been working to detect the presence of Asian elephants. And that's the opposite end of the spectrum. Here, I have temperatures as high as 50 degrees C, very hot, humid conditions. And in that scenario, I need to generate an alert, transmit it over a cellular or potentially a LoRaWAN connection, and inform the local community of the presence of elephants so they can mitigate human-elephant conflict. We can save the lives of both elephants and people. So how have I been going about this? Well, I've been actually looking at thermal technology to detect both of these species. When I first started this project, I looked at the use of a technology called a thermopile. And a thermopile is a passive infrared sensor split into an array. So it essentially gives you a pixel array in thermal of what you're looking at in front of you. You can see here that an 8x8 pixel array gives you quite a blurry picture of what's in front of you. But as you scale up that resolution to bit, say 80 by 64, you start to detect the presence of an actual animal. Now, this is a fantastic technology for me to work with because that low data rate of these pixel images in a resolution I can work with on a microcontroller means I can shrink models down in size and use thermal technology to detect the presence of an animal, use machine learning to teach the algorithm what the animal is, and then generate a confident alert and transmit that to community. And I've actually been looking at what's called a microbolometer as well. You can see on the right there, that's what a herd of elephants look like with a FLIR microbolometer sensor. And both of these technologies have given me the ability to really redefine what low-powered tiny ML looks like on the edge. So how good have we got it? Well, we've been taking models, but we've been using efficient det as our model itself. And we've been shrinking those down and running them on some really low-powered microcontrollers. You're talking about an ARM Cortex, an M4, for example. And with the FLIR Lepton 2.5, which has a resolution of about 80 by 60 pixels, we can get around an 80 to 90% confident detection at about 20 to 30 meters. Now that's excellent, because that means if an elephant or a polar bear is in the vicinity, 20 to 30 meters is enough time for us to actually generate an alert and transmit that to the community. We can start to deploy these systems at low cost on the edge. And it's not just the animals we're trying to detect as well, it's the people. We have to train the model to detect if a human is in the presence of the area, because that could be a conflict event, and also introduce other species. So cows and goats and species you may find in India, where we're going to deploy the system. We also need to detect them as well and teach that model what's an elephant, what's a goat, and what's a cow. We can't generate false alerts. These systems are designed to be deployed at scale, be community-based, and really work on the edge where they don't have to be maintained. They can sit there autonomously, and they just do their job protecting people and wildlife. Now in Greenland in Atokatumit, here's where we're going to put our system for the polar bears, an incredibly remote settlement. In fact, Atokatumit is one of the most remote Atokatumit is one of the most remote communities on our planet. The population is less than a few hundred people. Now, when we deploy the system in a town like this, it's imperative that the actual technologies that we use and share are also community-based, that we have a good user interface, that we enable the community to care for and maintain these systems. And that's key for me moving forwards with this project. For this to be a success, we need to look at how we can not just develop a solution, but also put it into the hands of developers, into the hands of coders, and make sure that they too have access to the technology and the environment we've created. So what we're looking at now is to actually go forwards and develop a final board. We're going to look at future trials of our efficient det model, and we're going to scale that down, run it in a TensorFlow Lite environment, and put that onto ARM boards. And the Wildlabs community is a perfect place for you to get involved in this as well, because Wildlabs is a space where you can meet, talk about these projects in the conservation technology world, work with Shah and myself, and really get to grips with what we're trying to achieve in the field. And if you get on board too in the Wildlabs space, it's quite a vibrant community. So you may be a hardware developer at heart, reach out, talk to some of the software team, and let's start to work on some of these solutions together, because we really feel we can make a difference in the field. So please do get involved, and we'd love to work with you and develop these solutions to help conserve threatened wildlife. I'm now going to pass over to Shah, who's going to continue today's presentation.
Thanks a lot, Al. It's great to be here today and talk to all you guys about what we're doing in conservation technology, both with Al's organization, myself, and Wildlabs in general, which I think there's a lot of really exciting work happening in that space, and there's a lot of eager folks. So I know that there's lots of tech people listening in today, and just know if this is an area where you're interested in working, there's a lot of projects out there that could use your expertise and would love to have you as part of it. So as Al and Fran said, I'm Shah Selbe. I started an organization years back called Conservify, which was actually set up as the first solely conservation-based makerspace and out there. And kind of our goal was to create the space in which we could develop technologies, open source technologies that would be used by our partners in the field to better understand the planet, protect the environment and the wildlife that lives there, stop poaching and illegal fishing and activities like that, and really kind of improve our ability to do good conservation. So in this picture here, you see my lab in downtown Los Angeles, where we build a lot of the tech and get ready for expeditions and deployments. Right now, the Conservify team is 10 people. So we have engineers on staff, designers, QA, project managers, and we have projects that we've deployed projects all over the world. So some of the things we've done in the past is drones. So we've done drones. Actually, one of the drone projects we worked on was with Al in the Republic of Congo around monitoring of Western lowland gorillas, but we've done stuff in Sri Lanka with blue whales, and here in California for coastal monitoring and protection around marine protected areas. We do a lot of work around development of sensors. So that's our major initiative is FieldKit, which I'll be explaining to you over the next couple of minutes what the focus behind that is. But really the lab is set up in a way that if somebody is interested in building something, they can come to us and we can hack something together and create some prototypes and test it locally and ultimately get to a place where we can test it out in the wild. So that's one of the exciting things about working in conservation technology is this stuff is it's not easy, right? We're building technology that's literally going into places that technology doesn't traditionally go into and has to withstand like some of the temperatures that you heard Al talking about, or function perfectly in the middle of a desert or a rainforest or a wetlands. And it's quite an exciting thing to try and create these solutions around these sorts of very difficult environmental constraints, very difficult data and power constraints. And so it's I think a place that's ripe for innovation, and we hope to see more tech folk and engineers interested in helping along there. So one of our major initiatives is FieldKit. FieldKit is something that started work that I was doing in Southern Africa in Botswana, around trying to better understand, monitor, and protect the Okavango Delta, which is a absolutely fantastic place in the northern part of Botswana. And so this was stuff that we were doing with the National Geographic Society. I'm an explorer with National Geographic and have been a fellow for a number of years around this conservation technology idea. And I think the premise behind FieldKit is something that a lot of people have thought about in the past. If you look at scientific tools today, specifically environmental sensors, you have the spectrum, right? You have the things that scientists have traditionally used, which tend to be very proprietary, really expensive, incredibly expensive, and not typically made with the most cutting edge types of technologies. And then on the far end of the spectrum, the other end of the spectrum, you have where, a lot of the work that both Al and myself have come from, where how do we use development boards? How do we use kind of the things available to hacker communities to try and answer some of these questions, right? Which is a fantastic way to learn and prototype and create an idea. But it's difficult to scale and to really get it to a price point that makes it have a big impact out there. And then the time that we're living in is a time that's full of these connected devices, IoT devices, and all the sorts of technology that, if harnessed in the right way, could mean some really profound and incredible things for science. And so our idea with FieldKit was, how do we target those very, high accuracy scientific tools, but do it with the development methodologies that we see happening in the commercial IoT space and places like that. I think there's a lot of opportunity for this sort of tool. And we decided that when we're going to do it, we're going to build it so it's fully open source, so that not only are we creating these tools for our partners to use or anybody who's really interested in using them, but we're building something that other folks can build upon and continue to evolve and make their own. So in a nutshell, what FieldKit is it's a suite of hardware, which I'll talk about. But it's also an app, and it's a website. And the reason why we have those three things is to answer some of the questions and serve some of the needs of users out there. When we first started building FieldKit, we were working primarily with field scientists, but we went out and we started talking to people and seeing if other people would be interested in using these tools. And we had a huge amount of folks reach out to us. So even beyond just the field science space, things like educators and their students, environmental justice activists, small municipalities that couldn't really afford these sorts of tools normally, citizen scientists. There's all these areas that would be interested in something if it was low enough cost and accessible in ways that we're aiming to do with FieldKit. But we've been continuing to work with partners like the National Geographic Society, the American Prairie Reserve, Smithsonian Institution, Wildlife Conservation Society, UCLA, to deploy FieldKit out in the world and start kind of gathering data and understanding what those user needs are. So a few of our pilot projects are deploying FieldKit in Montana at the American Prairie Reserve. We in December, right before the pandemic kind of hit the world, we were in Cameroon with UCLA on a National Science Foundation project to deploy FieldKit in the Shah Reserve, which is quite an amazing place out there in southern Cameroon. And for the last few years, we've been working with the Wildlife Conservation Society to deploy FieldKit across the entire Amazon basin to do water monitoring. So at its core, FieldKit is a microcontroller-based data logger system and a bunch of sensor modules that can be added to that. So we built it in a way that makes it very modular. And I mean, this is something that's like rather novel in this space. Like modularity in scientific sensors is not something that's ever been very easy to do. And we have been building FieldKit as that being our cornerstone because of that situation, because we wanted to create a better option out there. So basically our data logger, our current version of our data logger is based off a SAMD51, so that Cortex M4 microcontroller. But we're building these so that you can actually change this if you need to add different capabilities. You could just use a different design behind this data logger. Everything's open source. We're already seeing some iterations of this changing. So we have this current version that we're building a lot of now and starting to sell to people very shortly if they want to end up buying these. But we just kicked off a few new FieldKit projects around building a marine version of FieldKit, which, has very different design constraints. So if you wanted this thing to sit at the bottom of an ocean, like how is it going to look differently? And so that's something that we're working with the Smithsonian and MIT on, is creating this new version of FieldKit for these sorts of situations. But it's meant to be super modular. So if you have different capabilities that need to come in to accommodate, you can actually just spin up a certain version of the boards. We separated out the brains of FieldKit from the radio portion and the charging portion, because we understand that the radios change a lot, the needs of the radios for bringing the data back, and also power constraints change a lot. So you can just spin up a new version of that bottom board to work with the top board, and you don't actually have to do the full development effort for the whole thing. But the modularity is the thing that we're really excited about. So right now we're developing a bunch of different sensor modules. We have all these water quality modules, things like pH and dissolved oxygen and conductivity and water temperature. We've created our own FieldKit weather station. We've built water level, and we're just right now starting to design finished the design of our boards around air quality. So we're going to have a bunch of different air quality parameters, soil moisture, and the list of sensor modules that we'd like to design are long. It's much longer than my team could ever do. And so part of our hope behind making FieldKit open source is, if anybody out there wants to use FieldKit, they're the backbone of FieldKit to measure whatever weird and strange thing that they'd like to measure, all you have to do is spin up one of these sensor module boards, and we're creating all the dev tools to make it very easy to bring that code into the FieldKit ecosystem and run whatever sort of sensor module you want to do, and you can combine it with any of the sensor modules we've created or the community has created. And so we're trying to work on what that would look like right now. But it's exciting because it allows people not only to create their own types of boards, the things that they might be excited about, but also you could create these like versions of FieldKit that work well for certain situations. So you can have a FieldKit version that works well for measuring the sorts of things that are important in deserts or in rainforests, or you can have a California edition of FieldKit that's monitoring fire activity and seismic activity, things like that. And so we have like a lot of big ideas around how that would look in the real world, but really to help people gather the data that they need to make the good conservation and environmental protection decisions that they would like to do. So that the app part of, I'll talk very quickly about the app and the website, but the idea behind the app was, if you have a lot of people going out to gather this type of environmental data, we need an easy way to interface with the hardware, so people aren't using command line tools or, pulling SD cards and trying to run them through special software. So we created an app that actually allows you to configure and download data from the device, but it also will help the user as they're putting it out into the world, gather the right kind of metadata, the right kind of information about that deployment, so that if other people see your data, they can go back and they can look at that deployment checklist and the metadata behind it and say, you know what, I can trust this data. This data can be part of my study, or it could be used to make government decisions, or whatever it ends up being. So we've built this mechanism to try and help people gather things in a scientific way. And that's kind of the focus behind that. And then the last bit is a data visualization website. So, the Jer Thorpe is part of the FieldKit team. He was actually one of the kind of the founders behind FieldKit, and the idea. So Jer's a big data visualization person. He was the data artist in residence at the New York Times and innovator in residence at the Library of Congress for a number of years. And so he's bringing all that capability into how we visualize that data and explore that data. But since FieldKit's open source and we want it to be open data, so you could take that data out of FieldKit and put it into any system that you want. So we're building very kind of capable tools to bring data in and out and kind of mess with things, because I don't necessarily want everyone to store FieldKit, all their data in FieldKit.org, but they can actually do whatever they end up wanting with it. So how do we create tools that allow people to make better decisions and better integrate into those processes that they already have? That's the core goal behind what we're trying to do. So, there's lots of exciting things happening with FieldKit. I'm always very eager to talk to people who are excited about this sort of work and would like to help. So please feel free to email me or contact me if you're ever interested in kind of collaborating or you want to hear more about FieldKit. You could find more information about FieldKit on fieldkit.org. But yeah, I hope that some of you that are watching today are excited and inspired by the stuff that Al and myself are doing, and that maybe some of you will find a career in conservation technology, even if it happens to be on a volunteer basis or a full-time basis, whatever it is. You know, the state of conservation in the world is not doing as good as we had hoped. You know, I don't like getting into the dire statistics, but you know, extinction rates are well beyond what they should be at right now, and we're seeing habitats disappear and be destroyed. Climate change is a huge issue. So within conservation, we actually need all the help that we can get, and I hope that some of you will come along and help us. So please come to Wildlabs and become part of that community.
Thank you so much to our brilliant speakers, and thank you very much to the audience for joining us today. We hope that this has piqued your interest and you can see how you can play a part. So if you do want to get involved with conservation technology, please do join Wildlabs. You can find that at www.wildlabs.net. Please feel free to get in touch with Shah, Al, or myself via email or on Twitter. And to find out more about sustainability at ARM, you can visit the ARM website. We really hope that you've enjoyed this session, and we look forward to hearing your questions and continuing this conversation with you, and of course, seeing you at other sessions in this Global Goals track. Thanks very much.